What is going on, guys? My name is Brian Bausback, an undergraduate student at FSU, currently working in the University of Florida Surf Cohort 2019 under Dr. Kevin Knudsen, the head of the math department. For my undergraduate research project this summer, I looked at gerrymandering in the Florida House of Representatives using Markov chain Monte Carlo methods. But before we get into it, I'd just like to give a quick shout out to Dr. Daryl DeFord at MIT and Ruth Buck at MGG for all their support and help in this project. So first off, what is gerrymandering? So, gerrymandering is redrawing voting districts for one political party to gain an advantage over another. Obviously, this is something we'd like to prevent. Probably the most egregious example of that is in 2012 and 2014 in North Carolina, where all the Democrats in the state were compacted into these long, squiggly, snake-like districts so that their votes could be diluted. And in the state of Florida, it's not free from these type of districts, especially in the House. For instance, here in Leon County in Tallahassee, we have this boot-looking thing coming out of the Green District into Tallahassee. And in Manatee County, we have this long snake snaking all the way down to Sarasota County here. Additionally, if we look at the current Florida State House of Representatives split, the Republicans have 71 seats, while the Democrats have 46. But if we look at the percent of registered voters by political party, it's approximately even. So this raises a few red flags as well. So how are we actually going to analyze this? So, as I said, we're going to use Markov chain Monte Carlo, which is an algorithm whereby someone can obtain a sample of desired probability distribution by observing the Markov chain after a certain number of steps. So for us, one step is going to equal one new Florida House districting plan. And so we're going to generate 100,000 Florida House districting plans using a certain election, and then we're going to tally the total seats won by Democrats in each plan. So how do we generate these new plans? We're going to use a method called recom. So here we have our fictitious state of Blockania, and we have two districts up in here in the upper left, this purple district and this red district. So to perform recon, we're going to first combine those two districts into one giant district, create a spanning tree where each of the nodes in each of the districts is only connected by one single edge. Then we're going to randomly remove one of the edges, in this case this red edge here, to create two new districts, this new purple district here, this red district here. And for the state of Florida, when we were actually performing this, this is what our dual graph looked like of all the nodes and edges. But we can't just do this randomly, completely randomly at least. There are a few constraints that we have to take into account. First, all the districts that we create have to be contiguous. For instance, we cannot create something where this red district is completely separated from the rest of the red district over here. That's not allowed. Second, all the districts we create have to be as compact as the original districts. And third, within 2% of ideal population, or equal population, which means it's the total population divided by 120 for the number of districts or seats in the Florida House. So when we actually run this, we outputted every 1,000th plan in the 100,000 step chain. And as you can see, it's very varied and different, so we get a good sampling of that distribution. There's four elections that we looked at and created 1,000 step runs for. First off was the 2016 presidential election data. And to analyze this histogram, first we have the number of seats won by Democrats here on the bottom, and the number of plans in which they won that many seats on the y-axis. So you can see when we look at the mean, it's going to be 57 for the 2016 presidential race, 46 for the 2016 U.S. Senate election, 57 for the 2018 U.S. Senate election, and 57 as well for the 2018 governor election. So conclusions from this. Recall the Democrats currently have 47 seats in the FL House. They had 41 in 2016. And our three Markov trains predicted approximately 57 seats that they should have won, 46 for the Rubio Senate election. So based on this, we can say that the Florida State House of Representatives may be gerrymandered in favor of the Republicans, since all the plans, except for this one, included that they should have significantly more, at least 10 seats more. And this is after taking into account for the geographic advantage that Republicans tend to have, and also taking into account that Rubio won by a landslide in the 2016 Senate race against a relatively unknown Democrat. Thank you.